So, folks, we've got a couple of slides to start off, but before I put the slides up, I'll let you see everybody's currently smiling faces, because it's actually a rictus of terror, because not only is this event very interesting and exciting for us, it's also quite terrifying because of the potential for sticky questions. But we'll go around and we'll just introduce ourselves. So I'm Colin Turner. I'm Professor of Engineering Education at Ulster University, and I'll just let whoever wants to go next, go next.
I'm Victoria Sims. I'm a reader in developmental psychology at Ulster.
I'm Colin Kelsey. I'm a research associate in biomedical engineering at Ulster.
I'm Kelly Norwood. I'm a lecturer in psychology at Ulster.
Hi everyone, I'm Elena Mancuso and I'm a lecturer in biomaterials in the School of Engineering at Ulster University.
Hello everyone, my name's Apoorva and I am a final year PhD student. My PhD is on biomedical physics, so dealing with plasma and DNA.
And hi, I'm Michael Jennings. I'm a third year PhD researcher in Ulster University in the School of Engineering.
That's great. That's everybody. Hang on, and I'll over to see. I've suddenly now got some new dialogue whenever I go to share options. So I wasn't expecting that. Apologies. Let's see if I can. There we go. Right. All right. Hopefully you can see some slides. I'm just going to. We've done our little introduction. I do our little disclaimer. Of course, nobody knows absolutely everything. There's lots and lots we don't know, and science is as much about what we don't know as what we do know. And there are some questions nobody knows the answer to, but we will try to answer as many questions as we can get through in the time as we have as possible. And if you have others that we don't manage to get to, we'll see if we can produce those in a different format. So, without further ado, we've got a couple of questions to get us started here. One is, why doesn't the sky move? That's from Ashnan. And another question is, how much does a lightning bolt weigh? And that's from Will. And I think Colin's going to have a crack at answering that one.
Yeah, okay. So the first of all, the question about why doesn't the sky move? Well, basically, whenever you look up on a clear day with no weather, sure, you do see this, what looks like this completely still blue sky. And what's actually going on there is light of all colors is coming in from the sun, and whenever it hits the air above us, it's kind of deflected, but different colors are deflected by different amounts. So most of the different colors are going over your head, and then only the blue and violet, but your eyes are more sensitive to blue, so you see it as blue. That's coming down and you're seeing that. So the air up there, like, so whenever you go, thousands and thousands of feet in the air up there, even though it looks totally clear and still to you, it might be moving at, up to 1, sometimes 200, 300 miles an hour. But the key thing is there's always about the same amount of air above you, and the sun isn't moving very quickly in the sky. So as long as there are no clouds or anything up there that are being carried along as that air is moving, you see it as like this still clear blue area. And then so hopefully that answers that first part of the question, or that first question. The second question then, I think was it exactly, sorry, Colin? How much does lightning weigh? Was that it?
The next one was, how much does a lightning bolt weigh?
Okay, so there's sort of a few different ways to kind of look at this. The one sort of simple answer is, so lightning always forms, or almost always forms, in clouds. And what's going on there is, like, you have, in the same way that if you get a balloon and rub it on your hair, it'll gain static charge. If you sort of imagine inside a cloud, lots of little droplets are sort of moving down and then back up and down and back up. And they get charged up in the same way. And the reason that lightning kind of happens is eventually you get like a really big charge building up, and all of that charge has to like flow all the way back to the ground. And that's what you're seeing as a lightning bolt. So on the one hand, the cloud itself is really heavy. But on the other hand, the lightning bolt doesn't really weigh, it's just a flow of electricity. Like, it doesn't really weigh sort of anything at all, really. But one way, you know, but there is a huge amount of energy. And one way you kind of could look at this is, so it's like 1 to 5, between 1 and 5 billion joules. And if we look at like, that's instantaneous, and you know, it's just flowing through the air. But if we kind of look at that in terms of something comparable that kind of we would understand, like other ways of storing energy. So like if we tried to store that as if we tried to take that energy and store it as petrol and put it in our cars, that would take about 158 liters. Or if we tried to use that, so that's a huge amount. Like that's enough to, if I got in my car now and started driving on that amount of petrol, I could go all the way across, down through Scotland, down through England, right across through France, Germany, Poland, and I'd probably run out of petrol around sort of Belarus or something. So it's a huge amount of energy. If you were to store that in your car battery, then you'd fill something like 2,000 batteries, and it would weigh like 20 tons. Does that, hopefully that sort of answers that question a little bit there.
Sounds like a great answer, Colin. I'm just going to point out, a few people have already worked this out, but there's a Q&A button down at the bottom, and we've got a few great questions in there. But keep putting your answers in there, and we will try to go through as many of them as we can. We're just answering a few that we've got to start off with, a few that we got before we began. Some people emailed a few in. Here's a bunch of questions. We'll maybe just answer a couple of these first and maybe come back to them depending on how we get on. I think, Kelly, you were gonna answer, are unicorns real?
Just have to unmute myself there, sorry. Okay, can you hear me okay?
We can.
Okay, so sorry. So let's think about this in a way. What we do know is that science is fabulous, and science does give us lots of answers. Like, so just think of a small example. Whenever you're feeling poorly or unwell, your grown-up might give you Calpol. And what science has shown us is that Calpol contains this ingredient called paracetamol. And through science, we know that paracetamol will reduce your temperature. And for example, if you have any aches or pains, it will take them away. Now, science is absolutely wonderful, but as Colin pointed out at the start, it doesn't always give us the exact answers all the time. And as scientists, we need to keep looking for these answers. So this is a good way to start off thinking about unicorns, because unicorns do and did exist. But it's important to point out that these unicorns might be a little different from the beautiful white horses we see with the lovely manes and the single horn at the front, okay? So we're going to have to go back a bit in time, like 39,000 years here. And there used to be a unicorn called the Siberian unicorn, okay? Now, the Siberian unicorn is different from the typical now known unicorn, but it was still a very beautiful creature as well. So if you think about a rhinoceros that's really hairy and has a big horn at the front, you have got your Siberian unicorn. And Siberian unicorns were actually quite large. They weighed about 4.5 tons. And they were very picky eaters in that they only ate grass, and they're sometimes known as a prehistoric lawnmower. Okay, so that's a wee bit of evidence that is there for unicorns. And what then was discovered a bit more lately was in Italy in 2008, there was a deer. Now, we all know what sort of an animal a deer is, but these deers had the long horns at the front, and they were also called plateau unicorns. We have another type of unicorn, which is called a sea unicorn, and it's called a narwhal. And these are said to be the most mysterious creature of the Arctic. And there's about 180,000 of these living in the Arctic at the minute. So what do these narwhals look like? Well, think of a whale with a big, long tusk horn thing coming out the front. And scientists don't really know what the tusk horn thing is for. Some think that it's actually a tooth that has come up around here, and it pushes out, and it's like a sensory sort of mechanism for them to feel what is in their environment. But then there's also the theory that scientists think that they use this big tusk to communicate with. Now, so we all know what the modern day unicorn is, and there's stories of the modern day unicorn all throughout the world. So why do we talk about these unicorns? Well, I think it's really important to point out that when we're thinking about unicorns, we are believing in the beauty of nature and magic, and we all need a bit of nature and magic in our lives. And as scientists, we will keep on going to try and prove that these white mythical unicorns exist.
That's a great answer. There was all sorts of bits and pieces in there. That was fantastic. And I see we've got a few more questions we've still got on our slides that are pre-prepared, but we've had a whole bunch that have come in. So maybe we want to grab one of those. Who do you think we should get to answer something next? Vic, tell me who should answer what.
To Apurva, and she's going to answer a question from Shahida that says, why do we sweat?
So this is a brilliant question, and I'm going to start with a very scary word called homeostasis. So our body likes to be in a state of homeostasis, which literally just means that it likes to be regulated and keep in an equal balance. So the reason why we sweat is to keep our body cool. So whenever we're really, really hot, that we find that our face gets to the surface of the skin, and this helps to cool the body down. And sweating, whenever there is liquid on our skin surface, because our body is hot, it will try to evaporate that water, and by doing so, it'll make it'll cool our body down to that.
I hope that's everybody got that.
Yeah,
You're breaking up a little bit.
You're breaking up a little bit.
But I think we got that we're keeping our body cool from sweating. It was I think the end sentence. We have another question. Elena, I think, is going to answer this question, which is, why does my dad's sacral joint hurt in the morning? From Jimmy, who's 8.
So, hi, Jimmy, and I will try my best to answer this very interesting question. And actually, I'm really sorry for your dad, but I can perfectly understand him because I have a similar kind of issue in the morning. So basically, the reason of pain usually are very different, and these can perhaps derive from a damage or an injury, particularly to this kind of joint between the spine and the hip. So basically, these can be some kind of causes. However, as we age, so as in the adult age, our bones become stiffer, and as well as also the ligament. So in this case, what happens is that the cartilage, which is the kind of tissue between the bone and the really soft tissue, wears down, and this might be the reason for which the bones may rub together, causing pain. The reason for the pain that is probably more kind of severe in the morning is because usually movement helps to the relief of the pain. So basically overnight, being in the same position for several hours, these can cause, of course, the severity of the pain to increase. So basically, I, of course, am not a doctor, I'm a scientist, and I actually work in this kind of field because my expertise focuses on the development of materials, particularly for bone tissue. But this is something that I've been told several times, and actually the great suggestion is to basically improve both the muscle and the ligament. So the best thing to do right now is perhaps exercise, going for a walk, and not being in the same position for a long time.
Thank you. I think we have a question for Michael's going to answer this question about how are cheetahs the fastest land animal in the world?
Thank you. Yeah, good question. A number of reasons. Well, the first one is they're extremely streamlined. If you look at a cheetah, it's quite slender. Its skeleton is also constructed in a way that it will allow it to act a little bit like elastic. It can use its muscles to bound quite large distances, which removes a lot of friction, all the forces that sort of keep you down. But another thing is in its chemistry as well. So a cheetah, it has very little fat, but it has a lot of quick energy reserves. So this is a bit like a battery. It'll deploy all of its energy into a sprint of maybe not even a minute long. But after that, the cheetah just lies down. It can't do anything after that. So it's very fast, but it can't run very far.
Thank you, Michael.
And actually, we had a good question about sweating and the fact that humans sweat is one of the reasons why humans can run really far.
Oh.
What's next, Vic?
Sorry, I've just lost my chat bar because it's going so fast. Oh, Colin is going to answer a question about why is Mars red? Which is very apt because we have had the most exciting science event ever this week, I think. I don't know, what does everyone else think? Was it super exciting?
Yes, it was. So thank you. That is actually a really good question. And the really fast, simple answer is basically rust. The thing that makes Mars look red is basically it's iron oxide. It's basically the same thing that makes steel go from gray to red if you leave it to oxidize. Yeah, and actually the interesting thing is Earth would, well, yeah, actually lots of rocks on Earth have that same color. It's just that we have sort of, because we have sort of, well, lots of different things. I'll not get into this in huge detail, but yeah, basically the fact that we have living things on Earth is what gives us sort of all of the chemistry that provides things of, you know, with colors other than red. So you've got your blue water and your green plants and different chemical processes that produce rocks of different colors. So yeah, short answer to that one, but there it is.
I think we can see some questions. There's definitely some environmentalists out there who are asking some questions, and there was two really lovely questions about how does CO2 damage our planet and how do the trees help us breathe? And those two questions are completely connected together because of the amazing cycle that the universe is part of. During the Science Festival this week, we saw some amazing talks from really young naturalists called Dara McAnulty, some campaigners from Belfast called Anna Jennings. And these questions work perfectly together because all of these things are connected together. When we produce CO2, trees absorb those kind of products in the air and then give us oxygen to breathe. And that's why when we're as scientists, we're like, Kelly and I are psychologists, we do things about human minds, but we also understand how people want to protect the environment they're in and how the environment really impacts our mental health and our well-being. And one of those things is about having clean, fresh air around us and for us to be able to exercise as well. So those two questions are really lovely. I probably didn't answer them very well, but they're really connected together, so well done. I think we're going to move on to a question about the Earth orbit. I've just seen another one that says, how do we grow hair? Which I'm sure someone is super excited about answering. I know that there's people who will be very fascinated by that. But we're going to go to Michael because he's going to answer a question about the Earth and its orbit. Why does the Earth rotate?
Yeah, so why does the Earth rotate? Most planets rotate, all the ones certainly that we know about spin. And it's really about what happens. Well, first of all, it spins because there's nothing really to stop it spinning, so it keeps going. It's just spinning about itself. But where did that spin come from? It's mostly when it was formed. The Earth was, well, the theory is that it was formed by rocks crashing together. So if you take something like a sinkhole, you pour water into the sinkhole, you get this kind of spiral effect as it starts going down the sinkhole. It's roughly the same. It's something we call conservation of momentum. So the theory is that as it smashed together, it started turning a certain way. And once it started turning, there's nothing really to stop it. There's nothing big enough to stop it. So really good question.
Okay, I think I know someone who will want to answer this question. I'm just going to put him on the spot. Who is the most scientifically accurate superhero? And I think Professor Colin Turner may have an opinion on that.
Oh, scientifically accurate superhero. Gosh, that's really tricky. It might well be Batman, simply because Batman's got no superpowers, and all he's supposed to be is a really sort of clever individual. And you could say much the same about Iron Man, that they both of them have a particular superpower, which is having a very large amount of money and not a very large amount of sense. So they spend all their money making fantastic gadgets, which surprisingly are a secret, despite the fact that that would be very difficult to do. But they're probably the superheroes which are the most scientifically accurate, I guess.
Very good. I was expecting something more magical, but there we go. Elena, I think
I'll think about that one.
It's going to answer a question from Connor, or from Cara, from Cara, who is 8 years old. She wants to know, how do we grow hair?
Hi, Cara, and thanks, Emilia, for this really, really interesting question. So basically, the first thing to know is that when we are born, we actually are born with very little pockets in our skin, and these are called follicles. These are usually about 5 million. So basically, what happens is that your hair begins growing from a kind of root that is located in the bottom of these pockets. And this root is also made of cells of protein. So what happened then is that, of course, blood from the blood vessels arrive to the actual root and feed these, particularly because basically the blood flow carry on also cells, and this allows actually the air providing the right nutrients to grow. Of course, the air gets pushed up through the skin as it grows, passing on oil glands along the way. So basically what happened then is that this kind of glands keeps the hair, particularly those on the scalp, very shiny and soft. Of course, when the hair is to a kind of long enough length, start to poke out through the skin. And yes, I'm sorry, this is sad, but is that in this specific case that the hair start to die. So basically, it's also why this doesn't hurt to get an haircut. So I'm sorry for this, let's say, not really happy ending, but I hope that I did provide an answer to your question.
Thank you, Elena. I think we're going to go for a question. Well, I think Kelly's going to go and get something to help her answer a question, but we'll go to Michael to help us answer a question that is really oh no, we'll go for the cat question first because the cat's there. Eliza has asked, what is the strongest big cat in the world other than lions? And Kelly has her cat with her to help her answer this question.
Okay, Eliza, thank you so much for your question. I absolutely adore cats. I have this mini tiger and I have a normal moggy. So just let me talk about cats for a minute. So this is the biggest domestic breed of a cat you can get without a license. He is called a Maine Coon. Have you ever seen a cat this size? Look back, cousin. He is huge. He's like a big lion. Okay, so what is the question again? What is the most?
The question is, what is the strongest big cat in the world other than a lion?
That would be a jaguar. They're stronger than lions because of the shape of their mouth, and they can bite and kill with much success, including crocodiles. But the most dangerous cat in the world is called a black-footed cat, and they are from South Africa, and they have a 60% success hunting rate.
Kelly, your knowledge knows no bounds.
Thank you.
And what's the cat called?
Obi.
Obi, thank you for attending, Obi, this evening. We appreciate that. We're going to move on to the next question, which is a really cool question, actually. do people age differently in space? And I think Michael's going to take that question.
Yeah, short answer, yes. Yes, they do. And how do we know it? Well, first of all, a chap called Albert Einstein, who you might have heard of, you've probably heard of, he first theorized the theory of relativity. Long story short, if you're beside something that's very massive, time generally goes slower for you. And we're not talking like a lot slower. We're talking a second every, a second every 6 months or so. Not quite as little as that, maybe a bit more. But there's something really interesting where NASA sent an astronaut who was a twin. His name's Scott Kelly, and they sent him to the International Space Station for a year, and they did lots of experiments on him, lots of experiments on his twin, and then when he came back, they were basically comparing the two, and they saw that Scott Kelly did have signs of accelerated aging because he was in space for a year. So really good question.
I think we've got some other space-related questions that came into us before this session, so we might have a few of those for a little minute. And Colin's going to share them with us, I think.
Trying to get to my mute button, but there was a, can you hear? Yes, I think I'm off mute now. There was a question that came in that from Ricky, and that is, if I'm sat in a train and I'm moving at the speed of the train to move forward a carriage, I need to move faster than the train, so he needs to walk along the carriage. And in that case, the person walking along the train is moving at the speed of the train and the speed they're walking. And the question is, we're told nothing can travel faster than light. When driving at night, I turn on my car headlights. Does the combined speed of the car and the light break this speed limit? And if so, how? Now, actually, it is possible to go faster than the speed of light in some things. If you go faster than light in the speed of light in water, for example, you get a thing called Cherenkov radiation, which is this beautiful blue glow you'll see when you have nuclear reactors encased in water. But what you can't do is travel faster than the speed of a light in space or in a vacuum. And a very long time ago, like over 100 years ago, somebody tried to do an experiment to see if they could measure the speed of light as the Earth went round the sun, to see if they could detect a different speed on one side of the sun, let's say in winter, and another side of the sun in summer. And the idea was supposed to be to work out what the speed of light was going through a background medium that they called the ether. Don't worry about that too much. But the point is, what they discovered was that the speed of light that they worked out at both sides of those years was exactly the same. It wasn't different, it was exactly the same. They thought it was going to be the speed of light plus the speed of the Earth and the speed of light minus the speed of the Earth, but it was exactly the same. And they spent quite a few years wondering about what they'd done wrong in their calculations. And then eventually somebody sat down and went, well, what if they didn't do anything wrong in the calculations? And what if this is just the way light behaves? And that person was Albert Einstein, and that's how he produced the theory of relativity. So Einstein is often quoted as saying everything is relative, which he almost certainly didn't say, among many other things he's claimed to have said, because everything is not relative. In fact, the whole point of relativity or special relativity is that the speed of light is the same no matter what way you measure it. Whether you're going towards the light, away from the light, it's exactly the same speed. What you do get if you're going towards the light is the light becomes bluer, becomes what's called blue shifted. And if you're going away from the light, it becomes redder, becomes red shifted. And that's how we can detect when we look at stars and various other objects and galaxies, whether they're moving away from us or towards us. That's one of the ways we discovered that the universe was expanding. Oh, and while I'm on the way through, we had, was it Marcelo asked a question about what was there before the universe? Just simple questions like that. I love it when we get the really easy ones.
Is there a before the universe was the question.
What was there before the universe? It's a really easy question. It's just one of those standard questions. What we don't really know is the answer, but there's a little bit of evidence to suggest that if you look at the entire energy in the universe now, all of it, all adds up. There's negative energy from gravity, and there's positive energy from other things. And when you do the sums and add it all up, it looks like the amount of energy in the universe is 0. In other words, it may well be that the universe is nothing at all, but it's just very, very nicely arranged, so it looks like something. So it might actually be that before the universe, it was much the same as it is now. When we have empty space, it sort of fizzes with particles that come into existence, and then they meet again, and they cancel each other out. This is coming back to another answer, but and when that happens all the time, it's happening all the time in the space around you. And some scientists think that's how the universe was created, by something like this just spontaneously creating, and it might well create another universe in the future. There's a great scientist called Roger Penrose who certainly thinks that. So we don't really know, but that's some of the things that people believe might be the case.
So staying in space, I think we should go to Michael, because there's a cool question, a totally cool question from Gigi, which is, has anyone tried to model what aliens would look like if they lived on Jupiter or Neptune or Venus?
Short answer, yes. Yes, they have. We can have all sorts of good guesses without really any concrete solutions, but we can guess that if an alien is going to live on Venus, it's roughly the same gravity as Earth, but it's intense pressures. So we can say that they might be quite rugged. They'll have to be quite prepared for the high temperature as well. If they live on Jupiter, well, Jupiter doesn't really have much land. It's a gas giant, right? So the theory is the aliens would be flying. They would be airborne. Likewise, if it's on Neptune, it's a gas giant, so they might be airborne. So that's a really, really good question. Get you thinking.
Okay, I'm going to take a question, which is, why do boys have nipples? And that's a very interesting question, I think. As someone who's really interested in child development, one of the things that we know about is that lots of people think about genetics as being something that means that we'll all go one way. So the genes that we have are kind of deterministic. They mean that we'll go in one developmental pathway. But what we know is, imagine you have a big table in front of you and you've got sand on it, and you make lots of little grooves in the sand, and you tip it slightly to the side, and you take a little marble and you roll it down this kind of table with sand in it. The ball might go different ways down the grooves, okay? It moves about down those grooves in different ways, but we can kind of think about that slightly like genetics. The genes are there as a blueprint, but how the marble moves along those little grooves is shaped and changed by the environment that is around them. And this is the same about boys having nipples. Obviously, there's a function for female nipples, which is for breast milk and breastfeeding. But there's not that function for male nipples. And that's because at the very beginning, when you are in vitro, in the womb, in utero, sorry, that really little girls and little boys are exactly the same. It's just these different developmental pathways that we take that mean that we will end up being quite different, girls and boys. And you may end up being someone who's very strong and athletic, or someone who's kind of more like me. And that is all about these kind of different ways we move along these developmental pathways. So the reason why we have some non-functional aspects in our bodies is because that these developmental pathways that we take that occur in the womb. One of the most interesting parts, I think, that occurs in the womb is brain development. And have anyone ever seen a brain? It kind of looks like a cauliflower. It's got lots and lots of little grooves. And when babies are within the womb, their brains are quite smooth until about 2 months before they're born. And then the 2 months before they're born, you get all of these grooves coming into the human brain. That means that we can have billions and billions of neurons within our brain. It means that we can be very, very intelligent. And that, again, that development that happens is because of our genetic blueprint, but all of the environmental influences, even the things that we're being impacted by in the womb, are changing how our brains develop and how our bodies develop. So that's my answer. Right, I think, I'm sorry, Kelly, I am going to go to you because you are the cat queen. What breed of cat is most popular to be kept as pets in the world? I bet you know the answer to this question.
Okay, well, Opie's in the top 10. He's around the middle part, the Maine Coon would sit there. Now this is it's a very fluid answer because they're like dogs. Cats are trendy as well. So if we think back to a few years ago, Huskies were a very popular dog. And the same thing happens with cats as well. So the Maine Coon cat that was on screen earlier on, he has become more popular over the last few years. What at the moment you would probably find are the most popular are a cat called the exotic oriental short hair. Okay, so they're Siamese looking in nature without having the crossed eyes of the Siamese, and their short hair. And then at the moment, ragdolls, which are like a long-haired Siamese, so they've got a wee brown face, cream body, lovely piercing blue eyes. And I think within the top 10 there are those sphinxy looking cats, if anyone's ever seen one of those before. And of course the British short hair has always been a very popular breed as well. So I hope that answers your question. Thank you.
Okay, we've got a question. We have lots of people who know lots about gravity. So I'm gonna open it to the floor to answer this very complicated question, which is what causes gravity?
Well, okay, I'll start. I'll start with the simple explanation, which is gravity comes because matter or things that have mass attract each other. So no matter what things you've got, I've got a pair of glasses here and I've got a post-it note. And believe it or not, there's actually a small gravitational force between the mass and this pair of glasses and this post-it note, but you don't really feel it, you don't detect it. If you're beside something quite big, like for example, Mount Everest, you can see that Everest has some gravity of its own because it's really, really big. But generally speaking, you only notice gravity whenever you're in the presence of something which has got a lot of mass. So gravity is one of the 4 fundamental forces in nature, but it's actually a really weak one. It's much weaker than the electric force, which is what holds atoms together. And this is normally where, when I'm teaching this to my students in university and MJ is smiling, I usually get up in a chair and jump off it to demonstrate, but that doesn't translate very well to Zoom. So I'm not going to try that. But the point is you don't crash through your floorboards and into the center of the earth because gravity is actually quite weak. But when you've got really big objects like the earth has a big gravitational field. And it's very, very fortunate for us because it helps keep you stuck to it. And more importantly, it's keeping the air stuck to it. That's that sky you were talking about before, you were breathing. And Mars is a little bit smaller, so it's got a little bit less gravity, as MJ was saying. So if you were born on Mars, you might be rather taller as a result. So gravity is really caused by it acts on mass. There are slightly deeper explanations, but I think that's probably the place to stop. Unless anybody feels like going into the Higgs field. Okay, didn't think so.
I think we've got a lovely question from Lucia, which is, what steps do you have to take to work for NASA? And there's a really brilliant book called The Darkest Dark. It's a book by Chris Hadfield, and he talks about, he's been to space, he's amazing. And he was at the Science Festival a few years ago. And I think the biggest thing that you have to be to work for NASA is to be curious, to ask lots of questions, because he was absolutely fascinated by the sky. But lots of different people work at NASA, and there are really important differences. There are lots of mathematicians that work at NASA because we need lots of complex equations to get people into space. There are people who are fighter pilots who really understand how planes work, how we fly in the sky. There are people who are also pure scientists who want to be able to conduct scientific experiments out in space as well. One of the things that we do know from lots of the conversations that I've listened to on the radio, for example, from astronauts, is if you want to be the astronaut to go into space, you have to be very fit, because your body goes under a huge amount of pressure, I suppose. Maybe pressure is the wrong word. I think there'd probably be a better word than that, to be able to go into space, because it's really challenging. But I think the most important thing is that NASA needs people who are really inquisitive. I know someone who works for NASA at the moment. Her name is Kiva. And she is Kiva Rooney from Belfast, which is super exciting. And she's currently working in Belfast for NASA because she can't get to her job in America. But she has this amazing charity as well called Mathematical mathematic girls, because she really wants to make sure that other mathematical girls come and start to work for NASA. So I will put the link to her cool website into the chat box, because some people might be really interested in that. But I think the big thing is curiosity and lots of thinking. So next question.
It was great that you worked curiosity into a NASA answer there. In a week of Mars rovers, I feel that was particularly good. Thank you for that.
I think, Colin, do we have a few more questions that were kind of sent to us earlier on?
We do. Maybe I'll have a crack at Bo's question, will I? Kelly, I don't know if Bo's about, but so this is my stab at it. The question was, what is the most expensive substance in the world? And there's a lot of really very expensive substances. There's obviously things like gold and platinum and diamonds are very expensive. But actually the most expensive thing is a very unusual thing. This is unusual. Hello. So I'm going to have a crack at this. So the normal matter, like we're talking about my pair of glasses again, the things that you see all around you are made up of things called atoms. And inside atoms, there are other little bits and pieces. They've got little names, they're protons or neutrons or electrons. And that's what makes up all the matter around you. But it turns out that every type of this sort of particle, a proton or neutron or electron, has a kind of mirror image particle. And the one that's the opposite of the electron is called a positron. And positrons are a type of, we call them antimatter. That sounds very, if you've watched Star Trek, you should definitely know about your antimatter engines, but antimatter is the opposite mirror image of normal stuff. And antimatter is really, 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 really expensive to make. It looks like it costs about 10 trillion pounds to make a gram of it, if you could. I'm just going to check to see if I've got that down my back pocket. I don't. So I'm afraid you're out of luck. But if you really want to get a simple source of antimatter or positrons, my go-to example are bananas, because bananas have materials inside them that emit positrons, these antimatter particles, about every 75 minutes. So every time now you're sitting and watching a banana on your kitchen table, you can just remember that that is occasionally emitting the most expensive substance on Earth. Don't try to catch it. It's very, very bad for your health. Okay, I don't know if that worked at all, Bo, but that's going to be my best stab at it for now.
Fabulous. You got a thumbs up, Colin, which is what it's all about. Approve It is going to answer a question about how do trees help us breathe?
Hello. You know if the connection is okay.
We can hear you fine. The minute, Apurva. Keep going.
Cool. I'll keep going. So, do you all know about the process called photosynthesis? This is the process that trees use to convert energy into their food to help them grow. So the way photosynthesis works is the leaves, the green pigment in the leaves pull in the carbon dioxide in the air and the water from the soil and convert it to the chemical compounds, and the byproduct of that is oxygen. So actually trees don't use oxygen for their growth, so it is a waste product, and that's how oxygen is created. And if there were no trees, humans will not be able to survive, because the air in the atmosphere will not be suitable for breathing. So we really need the trees to convert the carbon dioxide into oxygen for us. So thank you.
I'm sure we're going to have some people with opinions on this on the panel. Do you think that people will actually be able to go to Mars soon? And that's from Rocco. So Michael is nodding yes. So Michael, tell us, why do you think that's the case?
Yeah, I'm a pretty big space nerd. Anyone that knows me knows I love space. So there's a lot of projects actually at the minute that are happening to send people to Mars. There's a number by NASA, but NASA's not the only one wanting to send people that sort of direction. There's a private company at the minute called SpaceX, and they're building a very large rocket called Starship, which hopefully in the next few years is going to make a trip to Mars. And the idea is they want to put 1 million people on Mars by 2050. Now that's a little bit narrow, that timeline, but certainly in the next century we might see a city on Mars. So it's happening.
Not just a few people, but a whole city.
1 million by 2050. Yep, that's their target.
Wow, amazing. Right, so I'm surprised by that. But very, very interesting. Would anyone like to answer the question about if you didn't cut your hair, would it keep growing? From Jerry.
That's really topical, isn't it?
My hair is keeping growing. I don't know about you guys.
I would say it depends. I mean, first of all, it depends on how old you are. So basically, in relation to my answer before, to this little pocket on our skin, of course, if these little pockets are getting old as well, of course, there is no kind of nutrients that arrive to the root of the hair. If these kind of pockets are, of course, well provided with nutrients, then the answer is yes, your hair will still keep growing. So I think that, yeah, it really depends on how old is the person. And of course, if you can provide all the nutrients in terms of vitamins and mineral salts to your body.
Thank you. There's a really cool question here from Sarah. That's, can you explain synesthesia? And synesthesia is a really amazing experience that some people can have where our senses get mixed up. So some people may describe seeing sense, so seeing smells, or some of the work that I do is in how people think about numbers, and people may actually think about numbers as having colors or having shapes. So some people would describe the number 9 as a certain shape. And that's because the connections in our brain have, we have a very typical pathway, as we were talking about, those blueprints that help us build our brains in a kind of typical way. But then sometimes those connections get a little bit jumbled up. Now, sometimes for people, synesthesia is actually quite stressful. It can be a little bit scary because some of the experiences you may have if you are a synesthete might be slightly overwhelming because you're not just seeing things, you're smelling them, you might be hearing them at the same time because of those mixed up pathways. But for some people, being a synesthete is really, really beneficial. So we know that some very, very good mathematicians experience synesthesia, and that seems to let them have access to these amazing problem-solving abilities. So that can be really helpful. Some very high-level musicians also report having synesthesia, and that may be because of that overlapping pathways that they have in their brain allows them to be able to see these complex patterns or experience senses to a higher level than many of us who don't have synesthesia. So synesthesia is really fascinating. It can be quite stressful, but it can also be a massive benefit. Colin, I'm going to ask you a question that I would really like to know the answer to, which is which reptile is as close to a dragon? Which is the closest reptile that we know to a dragon?
So there is actually,
my 3-year-old is obsessed with, by the way.
Ooh, there is actually a pretty big reptile called a Komodo dragon. I think they're about human length. They're quite slow. They don't have wings, so they're not very exciting in that sense. Most of those reptiles don't have any wings anymore. And they're also not very clean. They sort of just tend to ramble after things, and their mouth is so filled with pathogens and nasty bugs that they tend to just kind of bite things and then wait for them to almost fall over from the illness caused by the bite, as much as anything about vigorous running around after them. So there is such a thing as a Komodo dragon. I wouldn't recommend one as a pet. So they are sort of, they're definitely to be avoided, but they're quite slow, they're quite big, and sadly they don't fly, and they certainly don't breathe fire, which I have to say is very disappointing.
Okay, a question from Templeton, who's 8 years old, would like to know how long ago did dinosaurs live? And I think Michael's going to answer that question.
Great question. The short answer is dinosaurs are still living today. The crocodile is a very good example of that. It's something that hasn't really evolved since most other dinosaurs were wiped out. And the theory is most other dinosaurs were wiped out 65 million years ago by an asteroid impact, roughly in the Gulf of Mexico, where that is today. It's a really good question.
And I think birds are still technically classified as avian dinosaurs.
Okay, here is a question. So we're kind of talking about quite, ancient times, which I think is very, very interesting. Elvin, who is 6, is clearly doing a lot of thinking and would like to know, if people come from monkeys, why are there still monkeys? Why have all the monkeys not turned into people? And I'm hoping that someone will answer that question.
Yeah,
I think I can answer that. So basically, it's not that people and monkeys, it's not that we come from the monkeys that are alive now. It's basically there's a common ancestor between us and monkeys. So we evolved to kind of fill one ecological niche, and the monkeys evolved to fill a different ecological niche. An ecological niche is basically just a term that means, opportunity. So the way evolution works is, over generations, you tend to, there's a certain amount of variety in every species, and as things in their environment change, that sort of natural variation will make some members of that species better adapted and some worse. And the members of that species who are better adapted will tend to sort of go on and have more offspring, and so that adaptation gets stronger and stronger in that species. And basically the difference between humans and the other species of monkeys that are around today is that we're all basically really well adapted to do what we're doing. So we're really well adapted to like live in the modern world and farm, whereas monkeys are really well adapted to live in the jungles where they live. So that's why.
We've got time for just a few more questions, and we've got a question that I think we can round up with that came through earlier on. So there's a question about, does a full moon really make people crazy? And I think this is quite interesting because as psychologists, I'm sure Kelly might have something to say here too. We really want to understand what drives human behavior. Why do people do what they do? And there's quite a lot of history stories that tell us, try and explain people's human behavior. And one of them was about the full moon. And there's all of these ideas around werewolves and all of these kind of creepy things happening at the full moon. But actually, there's no real evidence that suggests that full moons or the kind of tides or kind of those kind of big environmental influences influence human behavior. But what we do know is that, as I said earlier on, more local environmental things affect our behavior. So things like how buildings are built and how the sounds go round buildings affects what we do. How we work in groups and teams in the environment also changes what we do. So there's no evidence that full moons change how we think, but there's lots of evidence that the kind of environment that we move around does influence how we think and problem solve. Kelly, do you want to say anything else?
No, because I'm just going to back up everything you said. There's no evidence to show that it does, but there have been some studies that have carried out that show sometimes ED, emergency departments, do see increases in numbers with the full moon. And my husband is actually a paramedic, and they do have a theory that in the full moon the calls are higher. Completely untested, but there you go, it's out there.
Okay. Would anyone, we really wanted to answer, there's someone who just loves cats.
I know.
Loves cats.
I'm with you, Eliza.
Does anyone want to answer what the difference is between a lion and a tiger from Ashnan?
I don't know.
I think, well, one has stripes and one has a really nice big mane. So I think we could go for that as a good answer. And I think there's another question.
Well, tigers are like a lot bigger, aren't they? They're like nearly 3 meters long as opposed to lions that are about. Tigers are the real king of the jungle. People call lions king of the jungle, except that lions don't live in jungles and tigers do, and they're bigger.
Yeah.
Sorry, that's my soapbox speech done.
We're stumped by those questions. They are very, very, very tricky.
They're amazing.
And I think, I'm not sure if we know the answer. Actually, this is a good learning lesson where we can say to Eliza, question here is, what is the cat with the sharpest fangs in the world? And I don't know. I don't think no one has put forward an answer to this one. So I'm not sure if we even know that. So we can hold our hands up on that one.
I want to say that the jaguar, because of the shape of the mouth, and it's the most powerful, not dangerous, the most powerful cat. So let's go for the jaguar because of the jaw shape.
Very good. And Margot, who is age 6, has asked, when were pencils invented? I'm sure someone could tell us what pencils are made from. One of our engineers.
They're made from
Eleanor.
graphite. Go.
Yeah, no, go. I mean, I remember vaguely, actually, in relation, of course, to the graphite, how it was embedded in a kind of wooden environmental shaping, but as far as I remember, they were invented around 1800 by a scientist who was serving the army of Bonaparte. So they were invented in Europe, in Bavaria, actually. Although the first reported use of a pencil has been reported back to several hundred years ago from the Aztec. So I don't know if the question was referring to the modern pencil or pencil in general. What do you think, Colin, in this regard?
No, I think that was a good answer. I think that's the modern pencil. I think you're absolutely spot on about how old they were.
Yeah. So
I'm sure
I'm amazed at the knowledge of this panel. It goes from pencils to dinosaurs to Mars to aliens to the human brain. It is fabulous. So we have 2 minutes left, and there was a really good question that we saw come through earlier on, which was, if you could ask any scientist a question, who would it be and what would you ask? Now that is a hard question.
That is.
So I'll start because I know exactly who I would want to have a chat to. There's a psychologist, a famous psychologist called Piaget. He's unfortunately dead now, but he's like the founding father of how we understand child development. And if I got to speak to him, he is famous for studying his own children. So he wrote books and books and books about his own children. And I would ask him, if he hadn't had kids, does he think he would have learned so much about child development as a scientist? That's the question I would want to ask him, because sometimes we as scientists we know we have to be very objective, but sometimes the things that we experience can really influence the types of questions that we ask. And I'd like to know about that from him. Anyone else?
I would want to ask Archimedes. Archimedes was a Greek mathematician, engineer, genius, who was unfortunately killed by the Roman army in Sicily. And there's a myth going about, I'm not sure if it's true, that he was drawing circles in the ground to try to preserve his work, and he refused to leave it. The soldier ordered him to leave. And so he was struck down, he was killed. So I would want to ask him, what were you writing down? What were you trying to preserve instead of saving your own life?
That's a great one. I would probably ask Roger Penrose about more detail about the question we got asked earlier on about his current theory for how universes branch off each other. What might be before the universe is other universes. He's got some very interesting thoughts on that.
Elena, do you have nope? I thought
I've always sorry.
Oh, I prefer.
I've always had a fascination for evolution. And so I think if I had a chance, I'd probably have a chat with Charles Darwin and see, you know, how he did the experiments and how he felt. I think that would be quite interesting for me.
I have one actually. He's not a scientist. He's actually a mathematician. But there's a very famous theory called Fermat's last theorem, written by a French mathematician, and it was finally in one of his notebooks. He jotted down basically, you know, I have a wonderful proof for this that's just slightly too big to fit in this margin. And then for years and years after this, people have been trying to sort of prove this. And it finally was proven by a guy called Andrew Wiles back in, I think it was the late 90s. But in order to prove this, he used like areas of maths that we didn't even understand, like, we didn't even know existed. Back in Fermat's time, we used supercomputers. You know, the proof runs to like thousands of pages. So I'd just love to know what this like really tiny compact proof that this French mathematician thought he had. First of all, I'd love to know whether it's actually right. And because if it is, it has to be something really amazing.
I think.
I'll keep on the animal thing. Yeah. I would like to talk to Steve Irwin. Not an official scientist, but he had a bit of an argument with a stingray for his final venture, and I would like to ask him if he knew they were so dangerous.
I think that we've maximized our time, Colin. So I'm going to hand it back to you. You're muted.
I know I'm muted, but I couldn't actually get to the mute control once I shared the screen. So apologies for that. I had tried to share the last couple of slides, but I think I've managed to mess up the dialogue. Folks, thank you so much for coming today and for all your questions. Thank you so much for the Northern Ireland Science Festival team, as ever, for all of their work and support. Thank you so much to the panelists for putting themselves through this quite scary ordeal where we just expose ourselves to whatever random questions we come up with. I know we didn't get to answer all your questions. I'm really sorry about that. We didn't get to answer, you know, is the Earth flat? No. We and all the other ones that there's a few others that we didn't manage to get to. But thank you so much for coming, and I hope you really enjoyed it. And maybe see you again this time next year.